Okay, so hello everyone. I welcome you all to this one of its kind session and initiative for AI in healthcare by Xpedicr Industry Private Limited. And I say one of its kind because this is not going to be a technical session. We are not here to teach you coding, and what we are going to show you and demonstrate is how you can leverage your existing expertise and knowledge to innovate and research in this field. We initially meant for this to be a small nudge, but seeing the enthusiasm of 100 plus people, we are more than happy to go all in into this. For that, we have planned a very structured internship program with planned activities and knowledge sessions. So stay with me till the end and let's get right into this. So the first two slides are for the young ones who asked me to discuss professional advancement in brief. The main thing that we want to emphasize on is to get into the loop. Now, AI is developing very fast. And if we have to keep up with it, we need to get into the loop at least. Keeping up with it can be dizzying indeed. The key here is to, at least stay in the loop. So we suggest that you get on LinkedIn ASAP if you have not already. I myself learned about it pretty late, but it is also where I got this opportunity from as a medical advisor first and then the co founder. So start with making a profile, even if it might feel lame at first because you don't have the achievements, certificates, and experience like others. LinkedIn is where you and your work get noticed. You get opportunities and get into the rooms you didn't even know existed. So if you want to break into a non traditional career like AI, startups, health tech, etc., LinkedIn is your launchpad. And I don't mean it for jobs, but for professional growth. If you have already taken the first step, the next step is to connect, like you are at conference with free snacks. I'm sure the young ones will be able to relate to this. Don't be shy. This is not the time for it. Send connection requests to doctors, AI folks, researchers, even that one person who made a great comment. Once you get there, believe me, you'll start seeing the opportunities. The next is that not everything works. You might feel that one of these opportunities is drastically going to change your life, but the reality might come crashing down on you. So be prepared for that, just don't stop. And by that, I don't mean endless scrolling for opportunities. Scroll with a purpose, not just to procrastinate or save the posts for future reference. Think of it as your professional Netflix, where you can pick a genre or field of your choice in this case, engage with some posts, and get similar recommendations. The most important point here is to be curious while you are at it. So you can stalk a little, check out people's background, the courses they did, their certifications and experiences, the groups they follow, and how they write, etc. And see if anything similar interests you. And when you have done all the exploration, express yourself. Even if it's just today I learned dot dot dot. You don't need to go viral, just be visible and maybe contribute some knowledge for the greater good. Let us now move on to why AI in healthcare and why now. I would like to bring to light a post by Mr. Ethan Go. He is part of the ARISE network, AI research and science evaluation at Stanford University. They have been working to compare the performances of AI alone, doctors plus AI, and doctors with traditional resources. The doctors were evaluated based on clinical management reasoning. That is, what should I do next for my patients? And they were graded by board certified clinicians. Guess what the results were? Doctors performed worse than both AI alone and a combo. What's even more surprising is that sometimes human AI collaborations performed worse than AI alone, simply because doctors undervalue AI suggestions. No, it does not mean that doctors will be replaced by AI, but it does mean that the medical community has to actively get involved to unravel this field. He concludes in the post by saying the skills doctors will have to develop is discerning what's credible and what's not. And that is more important now than ever before. To have this very skill, we all need to know the basics of AI at the very least. And we'll be covering it all in a very easy way. Before we start the theoretical part, I assure you that by the end of it, you will feel like a major player in this field. It might get a little overwhelming, but I've tried my best to make it very simple and medically relatable. So please stay with me till the end. And yes, I'll share the slides in the group as well. Also, I have not included any visuals because I want you to construct them in your own mind with imaginations. It will be like a practice. So, the first thing to learn from these terms is, of course, artificial intelligence or AI. It is the big umbrella term. Anything that can mimic human intelligence with the help of data and patterns is AI. Now, it encompasses a very broad spectrum of models and tools. Example can be a model or tool that suggests a differential diagnosis based on symptoms, or a simple one which understands what the patient is saying. The new model announcements that we often see in the news lie somewhere in this very broad spectrum. The OpenAI model that let you create Ghibli images, if everyone remembers, is AI. Now, it is very important to differentiate AI from automation. Automation is just performing repeated tasks without a decision making ability that mimics humans. Now, the next important term here is machine learning or ML. As the name suggests, it is how AI actually learns. So, you feed it data, which can be a patient data, and it will start spotting patterns. This learning can be supervised, where you give it correct answers it should ideally give, or unsupervised or semi supervised, as the name suggests, or it can be reinforcement learning, where you provide feedback for it to learn, and so on. The way it spots patterns is by algorithms, which use mathematical formulas. These algorithms form the basis of learning, which can be very simple decision trees. Like if I give you A, you do B or C, but if I give you D, you do E or F. And the tree can expand so on. The models can also be very complex, like neural networks, where there are nodes, layers, and lot of interconnections crisscrossing back and forth, much like the human brain, which is why the name neural network. These neural networks can be used to understand relationships in complex data. And there are many more methods and processes. A very simple example of machine learning could be to read ECGs. You give the machine 200 of them, it can separate normal versus abnormal patterns. If you give it 200 labeled ECGs, it might spot patterns of MI or LVH. Another important term to know is natural language processing or NLP. Now we know that computers have their own language of communication, which is the binary system. Similarly, for softwares, there is programming language. Now, what if we had an AI that will help us communicate with our natural or human language? That is exactly what NLP is for. It can understand what patients say, what doctors write. Such tools can be used to read or listen or translate or summarize all in human language. Examples of its use cases can be auto-generating case summaries from your OPD notes. The natural language here is your OPD notes, and the case summary as it is not coded into programming language. Similarly, we can have AI that does image processing, which is basically making sense of the images, which can be radiology or dermatology or perhaps endoscopy images. Now, Dr. Arnab and his team at Axoon Health have been working on such NLP solutions to solve the problems of endless paperwork in the hospitals, also by automating medical documentation. And Dr. Subrankar and his team at Autorad AI have been working to help radiologists and residents generate accurate reports in seconds. Getting back to the theory, we'll quickly talk about some interesting stuff you might have come across, like LLMs and agents. So, an LLM, which is called Large Language Model, is a super trained AI foundation model that has read everything: medical books, journals, patient interactions, and so on. Which, with the help of this huge data, which is its context, it generates output. It can write answers, draft reports, even mimic exam answers. It can simply operate on the basis of predicting the next letters or words, like ChatGPT does. So these models of OpenAI called GPT-3, 3.5, 4, etc. are all pre-trained foundation models that got better at prediction with more amount of data and features. Other models work differently. For an analogy, LLM is like a batch topper who has memorized Harrison, Bailey, and Robbins and never forgets anything. But ask something out of syllabus, it might start hallucinating answers. Now, these LLMs are very general purpose models and might not perform a specialized role very well. And so comes the concept of fine tuning. It is a machine learning process where a pre trained model like GPT is adapted to specific task or data set. Instead of training from scratch, we fine tune upon the general knowledge already acquired by the model to smaller domain specific knowledge. For an analogy, it is like sending that batch topper to do a short clinical internship in rural PHC so that they can still recall everything from Harrison, but now their answers are more practical and useful in the rural settings. Yet another method which we can use to make our AI work better is retrieval augmented generation or RAG. It is a technique that combines a large language model with an external knowledge source, such as the database or a document collection. So instead of relying on what it has been trained on, the model retrieves relevant information in real time and uses it to generate more accurate, context aware responses. So you can imagine that it will not simply predict something it does not know, but retrieve the correct information to reduce hallucinations and improve performances, especially on knowledge intensive tasks. Building on the previous analogy, if an LLM is the batch topper, With RAG, the same topper has quick access to up-to-date ICMR guidelines, etc., which get updated in real time. So when asked something tricky or out of syllabus, they don't guess, but they look it up from trusted resources and then answer, not just with the memory they were trained on. I hope everyone is with me till now. Let us now move on to a very interesting buzzword, that is agents. We learned about LLMs and better versions with fine tuning and RAG, etc. Now these fundamentally work on taking input prompts at each step from you to give suitable outputs. What if you designed a system to automatically do a specific task on behalf of you? That is what AI agents do. They are smart AI workers that don't just answer a question, but autonomously plan tasks and execute steps. They are built upon LLM, which can be fine tuned or not. And they can use some other tools as well. A very relatable example would be of a clinical intern in the emergency medicine department of the hospital. There, they have knowledge and a job to triage the patients. So instead of sitting behind and instructing every step, we give them some general instructions to follow, and they autonomously do the job, like check the patient file or symptoms, summarize vitals, decide the level of care needed, and then triage. Now, just like there might be variations in the types of clinical interns, there can be variations in these agents as well. Some might do a very straightforward job, while some might be designed to do complex jobs. You can imagine why, while designing or developing these agents, the developer might have some rule book or SOP in mind. That rule book, which agents follow to do tasks, is called the Agentic Protocol. Now imagine what you can do with a multi-agentic system, where each part or member or agent contributes differently and interacts dynamically. Um, Instead of having a single agent or worker to do a lot of complicated tasks, you can have multiple agents specialize in their own complex role, just like a trauma response team in EMD, where you have a triage team, ER physician, a surgeon, a radiologist, etc., who are working semi independently, collaborating in real time for one goal, which is to stabilize the patient. Now, why I say semi independently is because if we want the system to work responsibly, we have to give it some logic, like a trauma response SOP, which can be, which defines each specialist's role. That communication between agents happens through A to A or agent to agent protocol. Now, all of this is what happens in the front. What about behind the scenes? Here are the last two terms commonly used for behind the scenes. We learned about our agents, right? Now let's see how LangChain empowers our agents. LangChain is a framework to build a well-structured solo AI agent with a toolkit. It will give our AI model access to multiple things, like different language models itself, memory, tools, or real-time data. And these multiple components are chained together to build more sophisticated workflows. So it will make our AI smarter and context aware. For example, a clinical intern in EMD, if he or she is built on a LangChain framework, they'll ask initial questions via conversational LLM, then check the patient's vitals in real time from the monitor, pulls past medical records from the hospital system or using the document retriever, uses a risk scoring calculator, which is a tool invocation, and then decides.
whether to admit to ICU, urgent consult, or whether it is safe to wait using a reasoning LM. This might seem lengthy to us, but for AI, it is a matter of seconds. The very last term included is included because it is important and very often confused. It is the MCP or Model Context Protocol. You can guess what it is confused with. Agentic Protocol, of course. So MCP is a standard method which was developed by Anthropic to supply context to LLM. It tries to simplify the access of tools, services, and data for the LLM to give a well contextualized output. Earlier, we saw how multi-agentic framework can work as a trauma response team. But in real life, these agents might be from different vendors and might not have shared A2A protocol. So how do you plug all of them into a single trauma response system without rewriting everything, without rewriting every agent? You can use MCP. So MCP is the hospital-wide protocol glue. It doesn't replace your individual agents just because they don't talk the same way or they don't attach to you the same way. It ensures that all can contribute to a shared understanding. So your AI-based trauma response team still runs like a clockwork. That was all the theory of AI in healthcare. Now we'll move on to some use cases. The first two which I want to highlight is from our side, and it is only to demonstrate our capability, not excellence. So the first one here is a prototype for AI-based symptom checker and triage system made by our own AI/ML engineer, Jashanjot, in 2 days. It's not perfect, but it's a demonstration of the idea. So what it can do is it can take raw input from the patients. It can give a cleaned output with the help of LLM by correcting the spelling mistakes. After that, it extracts symptoms from the cleaned input, the duration, the red flag signs, and using some predefined rules, it will triage the patient. Now, the most important point here is that it has a fallback logic, which with which it can potentially prevent mistriage. It has to be made much more robust with much more complex logic, but I hope you see the role of medical professionals in designing such tools. We also did another interesting project called on Ecacare lab diagnostic data. So Ecacare is one of the pioneer companies in India for EMRs. Recently, they publicly released a few data sets that can be downloaded online. So this is one of them. It needed a lot of pre-processing. We had to delete the entries which were grossly mismatched or mislabeled and some missing values. For example, tests for urine and stool had samples labeled as blood. So these are the ground realities of the diagnostic system in India. We didn't want to take the chance of deciding which one was correct, so we just deleted those entries. And despite that, we had the data set with 48.8 lakh entries, which is a pretty good number to come to conclusions. An interesting thing to note here is that all this coding was done with the help of AI with step-by-step prompts. No engineer was involved. This is something called vibe coding and can be useful for simple tasks like this. Now, a very important role of medical professional is to give context to the data. So the tests are when doctors order, they are usually ordered in groups or panels. For example, hemogram or lipid profile. So analyzing the data set from that lens, which will be much more clinically relevant for public health planning, or for resource management by labs as well. So it took time, but now we have a data set from which much more useful information can be extracted, even for the analysis in future. So this is how we did it. We grouped the tests according to the line codes. Few other projects that we are working on is a small language model called Janshu for frontline health workers, with collaborations from AI/ML researchers and developers. And we are also making patient-centric data, which is translated into Indian languages with the help of agentic AI and human oversight. Apart from the work that we have been doing, as mentioned already, here are some other really cool use cases that we hope a few of you may work on during our internship. These are broadly categorized into three headings. Analytical AI. So, analytical AI are AI systems based on statistical machine learning for specific tasks. For example, predictive analysis, like predicting ICU deterioration early on, where AI models analyze vitals, labs, nursing notes, etc. in real time, not in just doctor rounds, to predict patient deterioration like sepsis or cardiac arrest, hours before clinical signs appear. Now, anyone who has worked in an ICU would know the amount of data gathered or can be gathered. Even with that, can we really predict outcomes unless there are gross changes? There might even be some pattern that can be used for prediction but not visible to us. And that is exactly where analytical AI can save lives before things go downhill. The next category is computer vision, which is a branch of AI that enables machines to process, analyze, and understand the visual data, which can be images or videos. For example, AI reading fundus photographs for diabetic retinopathy, where the AI scans retinal images and detects early stage retinopathy with high accuracy, even in rural clinics without ophthalmologists, which some humans might struggle to detect simply because of our visual capacity. And you can guess why this is cool. It brings specialist level screening to places with no specialists, that is, the ophthalmologists. The next category, pretty widely used, is generative AI, which can generate high quality text, images, and other content which humans can err or not make perfect. Yes, the Ghibli images creation is an example of Gen AI. Now imagine auto-generating discharge summaries from patient records. AI takes EMR data plus doctor notes to craft complete discharge summaries in seconds, saving hours of typing and potential mistakes. I'm sure I don't have to tell why it's cool. But my ultimate favorite use case is a hospital pod. Imagine combining all the above three categories. A patient enters the pod through camera, detects computer vision through camera detects the way the patient walks, expressions on face, etc. Analytical AI analyzes the patient's history, other gathered data to come to diagnosis and predicts the course of the disease. And Gen AI generates a complete report, diagnostic, and treatment plan. How cool is that? And now let me bring you down from the la la land. Recently, I came across this post from Mr. Anupam Mittal, which you might have known on Shark Tank. He mentioned a few important realistic things. The key takeaways here are that a lot of people are out there building the next big thing, but most can explain what stands in the way. And this is very important in a country like India, where we can't afford to spend resources to build things that might have flaws or might not even be useful. So, a great advice here is to study the detours, including exaggerations, the obstacles, the limitations, the implications of the limitations, and so on. With that in mind, we'll quickly see limitations of AI in healthcare. So, AI in healthcare isn't all magic. It has real risks if not used carefully. For example, bias in data means biased AI. You can imagine how harmful it can be in the healthcare sector. If the training data mostly comes from one gender, ethnicity, or hospital, the AI might make poor predictions, or at worst, wrong predictions for others. Then comes hallucinations, like discussed previously. LLMs like ChatGPTs can sometimes generate completely wrong answers that sound very confident. For example, they can literally make up dosages, invent studies, or suggest non existent syndromes. And when you prompt the right answer, it will agree that it made a mistake. Now, imagine doctors making such mistakes. And which is why a very dangerous precedent is over reliance by users. Now, the users may be doctors or common people. Doctors may trust AI blindly, skipping their own judgment, or patients may over rely on AI suggestions. This is dangerous if the AI is wrong or misses a rare condition. Just yesterday, I saw this post which very nicely shows what bad data can do. So, bad data with machine learning will give you polished bad output. Bad data with artificial intelligence will give you a very confident, polished bad output. Bad data with generative AI will give you a decorated bad output. And with agentic AI, it doesn't just give you bad output, but it acts upon it, takes decisions, triggers workflows, and does it repeatedly. So, key takeaways here are to clean your data, validate assumptions, and align with real world objectives. Now, on the other side of the spectrum, um, if the AI gives diagnosis but can't explain why, doctors can't verify or trust it, especially in critical care. Another important concern, which Gypmerites and Insonians may very well know, is of privacy and data leaks. If we store or transmit data without proper encryption, it can risk breaches of sensitive health information. And lastly, the regulatory and legal gaps. For example, who is responsible if AI makes the wrong call? The doctor, the developer, or the hospital? It is still very unclear in many places. So you see, AI is like a very big universe in itself. Now, we have curated 5 places or roles of medical professionals in AI in healthcare product development, which are non technical. These are curate real world problems, actively spot everyday pain points, delays, errors, repetition. For example, ask yourself, what do I wish I didn't have to do manually? And these should be backed by data, which can be quantified, like so and so amount of time gets wasted in repetition, or qualified, like so and so causes extreme stress on the doctors. The next step is to observe care processes and design workflows. Map how care actually happens and not just textbook protocols. Define the steps, who does what, and where exactly AI can assist. The next role is to label and curate data with context. This is something which we learn in the course itself to understand the meaning of any information given to us medically. So, our role is to provide clinical nuance and logic, which machines might miss due to oversimplification or generalization. The next role is to test AI tools critically. We can check if outputs are clinically accurate, safe, or ethical. We can also validate the tools against real world cases and not just clean data. With all of this, we should be able to suggest targeted improvements. at any step to pinpoint what didn't work and why, and how it could be done better. So we have to recommend tweaks based on our on ground knowledge. Now, do we need a specialized course to do our role? Maybe not. We designed a 3-step learn and do it yourself framework based on your own experience. The very first step is to get curious, understand the basics at least. And you know what's the best part? You can use AI itself to learn about AI. Just ask it dumb questions and learn. Now, you have to be a little careful though. Try to verify wherever factual matters come up. But for routine simplification and analogies, you can use AI. Also, Perplexity recently launched on WhatsApp. With it, you can get well cited answers for your small questions. So just go ahead, ask dumb questions, and debate with it and learn. Don't simply copy though. It can make you dumber if you let AI do all the thinking for you. Step 2 is to try out the tools which require no or minimal coding. You have to spend time on this. I'll leave the rest of the information for interested ones to try out whenever they want to do it. The step 3 is do it yourself or the project building loop, which involves your role as mentioned earlier. So start with a small pain point. Workflows can be broken into input, logic, and output. Then use AI tools to build one part at a time, which might need a lot of back and forth, but you have to be very patient. Then test it with your friends or mentors. Try to use diverse methods and data. The last step is to repeat, improve, and document, and there you have your project portfolio. With this, in weeks, not years, you might go from AI sounds cool to I made this. Or you might give up altogether. For that to not happen, we have a message for you. Remember that your main moat is not code or even knowledge, but your clinically tuned brain and training. You are the bridge between clinical reality and AI fantasy. What we provide at Xpedicr is a playfield for you to explore, learn, and implement high quality and real life use cases end to end. You can pick a project of your choice, build portfolio, which can be case studies, mini projects, research ideas. Document every step and method of it. Throughout your journey, we'll support you in the execution with 1:1 guidance, group discussions, and brainstorming sessions. We'll also help you connect with people who will actually implement your ideas or give you feedback. By the end of this certified clinical internship, you will have the required knowledge, be trained, and will have contributed to a real AI product, prototype, or workflow. And you will also be ready to take your first steps into health tech R&D, consulting, or product management, or startup role as advisor, co-founder, or CMO. You will also get appropriate networking and visibility for your work, which might potentially unlock future opportunities for you, including at Xpedicr. The internship starts from 1st June 2025 and its structure is as follows. In the first month, you will have clinical discovery and design thinking. Month 2 will be for data and regulation with developer onboarding to implement your ideas. Months 3 and 6 will be collaborative AI product development. And lastly, program wrap up and recognition. Now that this buffer time till 1st June is for you to explore AI in healthcare yourself. See if it's up to your taste and maybe gather some skills like basic programming and so on. The 6 months duration is to provide you ample time to make something useful and not just hackathon winnable project products. The timings for engagement will mostly be in the evenings or on weekends. A few guest lectures will also be scheduled, which can be attended by others too. So you can stay in the group for updates and some more interesting stuff on AI or other emerging technologies in healthcare. With this, we conclude the introductory session. The WhatsApp group will be open for Q&A always. Thank you all for staying till end. I hope this was useful.